Yeah, welcome back to another episode of our ideal gas equation. In today's class, we are going to be looking at the calculations involving ideal gas equation. If you have not watched our first video where we derived the equation, kindly check the description below to go and watch that and then catch up with us in this upcoming section. I remain your tutor, Latif Ismaila Akanbi. If you have not subscribed to my channel, try to do so now and click the notification bell for my subsequent content. Then, let's move on. Example 1. The amount of air in a motor tire is doubled. What will be the relative change in the pressure of air in the tire if the temperature and volume of tire are constant? We were told that the amount of air, that is the N value, in a motor tire is doubled. Then, what will now be the relative change? That is, what will be the pressure? What will the pressure be when the number of amount of gas in that tire is doubled? If you could recall, from the ideal gas equation that says PV is equal to nRT, we have some derivation in our last class that the pressure is directly proportional to amount, meaning the higher the pressure, the higher the amount. Now, let me say we remove the proportionality, we put P is equals to Kn, where our K is equals to 1. Then our amount from this question is doubled, meaning 2N. That the amount is doubled. So which means, if you now come to this place, when amount is doubled, anywhere we see N, let us put 2N. So from here, P is equals to, our K is 1, multiplied by 2, multiplied by 2. So P will now equal to 1 times 2, we have what? 2. Definitely, when our amount is doubled, then our pressure also will be what? Double. So the relative change in the pressure of air in the tire will also be doubled. So the pressure will be doubled. So that is the answer. So the answer is the pressure of the gas in the tire will also be doubled. Example 2. Calculate the volume occupied by 2.5 moles of an ideal gas at minus 23 degrees Celsius and 4.0 atmosphere, where our R is 0.082 atmosphere dm³ per Kelvin per mole. Let us analyze this. Calculate the volume. Want to calculate volume? Unknown. Occupied by 2.5 moles. Anything in mole means amount. That is N equals to 2.5 mole of an ideal gas at minus 23 degrees Celsius. Our temperature is minus 23 degrees Celsius. You have to convert this one to Kelvin. How? Minus 23 plus 273. Are we there? So we have what? 250 Kelvin. We've converted it to Kelvin. Next, and 4.0 atmosphere. Anything in atmosphere refers to pressure. Pressure equals to 4.0 atm. And you are given value of R to be equals to 0.082 atm dm³ per Kelvin per mole. From here, let us now apply our formula. PV is equals to nRT. We need to find the value of volume by dividing both sides by pressure. V equals to nRT over what? Over pressure. So what's our number of mole given here? 2.5 multiplied by our R 0.082. The temperature we just calculated, 250 Kelvin, divided by the pressure is 4.0. Now, let's multiply the numerator and divide it by the denominator. So we have 12.8. And the units of volume now is what? dm cube. So 12.8 dm cube. So let's take one more example again. Now, example 3. Calculate the volume occupied by 3.2 grams of dry oxygen gas at 300 Kelvin and 100 kilonewton per meter square. Given a gas constant to be 8.31 joule per mole per Kelvin and one atom of oxygen to be 16.0, that's the molar mass of that oxygen. From here, let's take out our parameters. Calculate the volume. Volume is to be calculated occupied by 3.2 grams of dry oxygen. Mass of oxygen, 3.2 grams. At 300 Kelvin. Temperature, 300 Kelvin. And our pressure is 100 kilonewton per meter square. Are we together? If you look at this, from our ideal gas equation that says PV is equal to nRT. From here, we don't have our N, but we can get our N because we are given mass of oxygen. Amount equals to mass over what? Molar mass. So from N equals to M over molar mass, our amount will now equal to, our mass of oxygen is 3.2 over the molar mass given to us, our molar mass of oxygen. Don't forget, oxygen is O2, meaning oxygen 16 multiplied by 2. So N equals to 3.2 over 32. So we have it to be 0.1 mole. So amount of oxygen is 0.1 mole. So going back to this formula, PV is equal to nRT. To get our V, you divide both sides by P. V is equal to what? nRT over P. So let us now input our values. Our N is 0.1 multiplied by R given to us, 8.31, multiplied by our temperature, 300 Kelvin, divided by our pressure, 100. So we multiply. What do we have? So we have 2.493 in where? Decimeter cube now. So approximately 2.5 decimeter cube. So the volume given to us that we get now is 2.5 decimeter cube. So don't forget to like this class and leave a comment as we move on this. So let's take another example as we move forward. Example 4. Calculate the volume occupied by 0.125 mole of oxygen at 27 degrees Celsius and 2.02 times 10 to the power 5 Newton per meter square pressure. Given 1 mole of gas occupies 22.4 dm cube at STP, standard pressure equals to 1.01 times 10 to the power 5 Newton per meter square. This question looks like an ideal gas equation, but nevertheless, it will lead us into what we call general gas equation. Now let's go on. Calculate the volume occupied by 0.125 mole of oxygen. Please, to calculate this volume, this is not the first volume. The volume 1 will be the volume occupied by this amounts of gas, of oxygen. Are you there? Now you are given the amounts of that gas of oxygen, and we are told that 1 mole of gas occupies what? 22.4 dm cube. 1 mole occupies 22.4 dm cube. Are you there? At STP. If that is the case, 0.125 mole of that gas will now occupy how much? Cross multiply 1 times x. S equals to 0.125 multiplied by what? 22.4 dm cube. So S equals to, let us multiply it together. So we have 2.8 decimeter cube. Now, we've gotten the volume of our oxygen. So it's going to be our V1. So let's now go back. Our V1 equals to 2.8 decimeter key. Now, calculate the volume occupied by 0.125 mole of oxygen at 27 degrees Celsius. Our T1 is 27 degrees Celsius plus 273 to be converted. So we have it to be, we have 0, that is 300 Kelvin. And 2.02 times 10 to the power 5 Newton per meter square. Our P1 is 2.02 times 10 to the power 5 Newton per meter square. Then we can now move on into the other aspects. Our V2 now is what we are looking for. Our T2 is our standard temperature, which have the value of what? 273 Kelvin. Then our P2 will equals to the pressure given to us, 1.01 times 10 to the power 5 Newton per meter square. So from here now, let us now apply our gas law. P1 V1 over T1 equals to P2 V2 over T2. Cross multiply, we have P1 V1 T2 is equals to P2 V2 T1. Now I want to get my V2. I will have to divide both sides by P2 and what? T1. So our V2 will be equals to P1 V1 T2 divided by P2 T1. What's my P1 from here? My P1 is 2.02. What's our V1? 2.8. What's our T2? 273 divided by our P2, 1.01 times 10 to the power 5. Then our T1, 300. Let's cancel this. Now let's multiply the numerator and divide by the denominator. Please, when you are doing your multiplication, 2.02 times 2.8 times 273, divide by 1.01. Then divide it again by 300. That is how we are going to get the perfect answer. So we have 5.096 decimeter key approximately to 5.10 decimeter cube. Now, we cannot see how easy to calculate the ideal gas equation. From this, you can use this approach to solve so many questions based on ideal gas equation. If you find this class so interesting, kindly subscribe to my channel and click the notification bell for my subsequent content. And don't forget to share, like, leave a love emoji plus your own comments. It really helps in going far on this channel. I remain your loved one, Latif Ismaila Akombi. Watch out for another topic in chemistry.